In this video, we're going to go over strengths of acids and bases. So the strength of an acid depends on the extent to which the acid donates a proton to water. And the strength of the base depends on the extent to which the base can accept a proton from water. Both strong acids and strong bases can be highly corrosive, but as dilute solutions, they are generally safe to handle. So strong acids dissociate completely in aqueous solutions. All the acid molecules or ions have donated a proton in water to form the conjugate base and hydronium ion. So you can see in this picture that when hydrochloric acid, which is a strong acid, is put into water, it is called 100% ionization, where all of the HCl molecules dissociate and break up into hydrogen plus and Cl minus ions. Weak acids do not completely dissociate. So if you have acetic acid, some of the molecules will go into hydrogen ions and acetate ions, but then there will be some that remain as acetic acid. Hydrochloric acid is the only strong acid produced in the human body. It's produced in the stomach where it aids in the reaction involved in digestion, and its concentration ranges from about 0.01 to 0.1 molar. This is another image of strong acid dissociation. When you add HCl to water, all of it dissociates into chloride ions and H3O+. So the hydrogen from the chloride, or hydrogen from the HCl binds with the H2O to make the H3O+. The list of strong acids are nitric acid, sulfuric acid, perchloric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. And their conjugate bases are shown. You can assume that all other acids are weak acids. Strong bases dissociate completely in aqueous solution, producing hydroxide ions and conjugate acids, or cations. Ionic compounds composed of hydroxide ions and group 1A or 2A metal ions are strong bases. And strong bases of soluble ionic compounds are strong electrolytes. So we have sodium hydroxide, and you put it in water. Sodium hydroxide will break up into its ions of sodium positive cation and OH minus anion. These strong bases are barium hydroxide, calcium hydroxide, lithium hydroxide, potassium hydroxide, sodium hydroxide, and strontium hydroxide. You can assume that all other bases are weak bases. So to practice, nitric acid, which is a strong acid, that is used in a laboratory. Write the chemical equation that shows the reaction of nitric acid in water. Then label the acid, base, conjugate acid, and conjugate base. Let's go ahead and pause the video and work it out, and then we'll come back together and do it together. Okay, so we're going to write the chemical equation of HNO3 in water. Remember, an acid donates an electron, donates a hydrogen, so the water is going to take the hydrogen from nitric acid, and you're going to get NO3 minus plus H3O plus. And these are both aqueous because they're an aqueous solution. Label the acid, base, conjugate acid, and conjugate base. Nitric acid is the acid. Water is the one that accepts the proton, therefore it's the base. The acid, after it loses its hydrogen, is now the conjugate base, because an acid turns into a conjugate base. And a base, after gaining a hydrogen, now turns into a conjugate acid. To what extent is nitric acid dissociated? Nitric acid is a strong acid, which means that it is a 100% dissociated. In an aqueous solution of nitric acid, an electrolyte. So an electrolyte is when it breaks up into ions. Because it is dissociated, it breaks up into it shows right here, it breaks up into H3O plus and NO3 minus. It breaks up into its ions. So yes, it breaks up into ions. So in summary, a strong acid dissociates completely in solution. The common strong acids are nitric acid, sulfuric acid, HClO4, perchloric acid, HCl, HBr, and HI. In solution, a strong acid contains mostly H3O plus and the conjugate base, and very little of the acid, because it goes to 100% dissociation. Strong acids are strong electrolytes because they produce many ions in solution. Ionic compounds composed of hydroxide ions and group 1A or 2A metal ions are strong bases, and they are also strong electrolytes.